Welcome to Data Science with EJD. In this video, I'll be talking about Introduction to Machine Learning. In the previous video, I had talked about Introduction to Data Science, and machine learning is a subset of that. So, that's to say that after this particular video, I'll begin to do practical. So you see Python codes and all of that for different aspects of machine learning that we're going to get introduced to right now. Introduction to Machine Learning. Of course, this is the link to my channel where you can find all the playlists leading up to what you are going to learn here because you need some background, like you need to know some statistics, some probability, some linear algebra, talking about matrices and vectors, some calculus, basic calculus like differentiation, integration, and all that. Okay, so talking about machine learning now. Um, okay. First of all, what is machine learning? So here, when we define data science the other time, we said it actually blends together statistics, some mathematics, blends together coding and domain knowledge. But machine learning is something specific when we talk about data science. So something a bit more specific. So machine learning talks about algorithms that learn patterns from data to make predictions or decisions. So it's more like you're making a computer to learn from data and see patterns from those data. So it's a bit not like when you what you do in data analysis where you do that yourself. So but the machine like it's more like an automated learning process, from data. So and we have different types of machine learning. We have supervised machine learning, and we have unsupervised machine learning and reinforcement machine learning. Okay, so when you talk about supervised machine learning, you have examples like linear regression, logistic regression, support vector machines, and you have unsupervised machine learning like k-means, clustering, principal component analysis. Then you have reinforcement learning, which is whose example is like q-learning. So we're going to take these things one after the other and break them apart so you can understand the concepts properly. Okay. I think the basic difference between supervised and unsupervised learning is the fact that for in supervised learning, you work with labeled data. I think that's the word, labeled data. So you can actually say data one, row one, column one, and things like that. But for unsupervised learning, the data is all over the place. You cannot actually pinpoint the data is not labeled per se, right? And for reinforcement learning, it's more like the more you add data, the more the system learns. And then when it's just it's more like you're playing a game. Once you do right, you get some point, thumbs up. Once you do wrong, you get some thumbs down. And that's how the system learns, kind of. So, and you have applications in places like image recognition. When you talk about convolutional neural networks, you have natural language processing, as you have in transformers. Transformers are becoming a big deal now that generative AI has become very common like that. Then you have recommendation systems. Recommendation systems like maybe you have a system that tells you the kind of video to watch and everything. I mean, we have this all over the place, like on YouTube, based on the kind of videos you have watched in the past. So they recommend videos for you based on that, right? So that's a very good example of machine learning right there. Okay. In history, we have things from perceptrons in the 1950s to deep learning in the 2010s. If possible, under this playlist, we are going to talk about deep learning at some point. Let's see how far we can go with that. Okay, so for roadmap and free learning, you need skills in Python. You need to know basic things in Python, which I've also taught already. So by looking at the data analysis with Python playlist, you can get all the information you need about this Python thing. Then you need some math idea to like calculus and linear algebra. You need to also know about model evaluation, as you're going to see as we move on. Then you need tools like Kaggle where you get data sets, and on Kaggle also you have machine learning competitions going on there. So those are very good places for you. Then you need Google Colab and or Jupyter Notebook. You can use either of them, and you can use if a code from Jupyter Notebook, you can upload it in Google Colab and you can operate it there. Now, the beautiful thing is that Google Colab, if you have large data sets and you have big space to accommodate data, so you can easily upload data sets on Google Drive and call it from Google Colab to run. Of course, you have to be connected to the internet. So Jupyter Notebook also does the same thing, except that you don't have to be always, you don't necessarily have to be on the internet because that uses a local host, right? Then you have other resources. Of course, you have resources on my YouTube channel, like yeah, you have already seen, and I'm still going to show you before this video ends. And then of course you have Coursera and all these other platforms. Fast AI, you have several videos on YouTube, but my videos are particularly helpful because my code sheets and data sets are all available. Just look at the description in whether your Facebook or on YouTube. Just click on the link in the description. It will lead you to a Google Drive where you can download all my code sheets and my data sets. So if I always advise that you download all of those first, so that as I'm doing it, you do it after me, so that because the best way to code is to code, right? You don't just watch a video and later when it's time to implement, you're stuck. So as I'm doing it, you can pause the video, try to tweak things. If you see a number, change it and see what happens, and that way you continue to learn. So you can, but by the time you build some confidence, you can begin to build projects like you can participate in Kaggle competitions, you can join machine learning communities, e.g., like on GitHub and all that, right? So we go on to Python for machine learning. Of course, Python is more like the most popular language when it comes to machine learning, like that. So of course, you need basic setups like Anaconda, where you get Jupyter Notebook, VS Code. Then Google Colab automatically comes with Google if you have a Google account. You need to know about Python basics like variables, data types, conditionals, loops. You need to know about functions like modular code, library imports, the kind of libraries you need. I mean, for machine learning, one of the key, the most popular, one of the most popular libraries will be scikit-learn, of course, and then you have TensorFlow and PyTorch for other things as you're going to see. So you need to know about Python data structures like list, dictionaries. You need to know about NumPy, which is good for arrays for machine learning data. So for machine learning libraries, you have NumPy, which is good for arrays, just like I said, and matrix operations like dot products and all that. You need scikit-learn for things like linear regression, support vector machines, k-means clustering, principal component analysis. We are going to do this. We are going to take these things one after the other after this video, and look through the code and see how these things are implemented. Then you also need TensorFlow and PyTorch. If we go as far as talking about deep learning and neural networks, we'll be talking about that. Then an example will be so one library you can do is scikit-learn, right? So from sklearn the linear model, you can import linear regression. That's if you want to do linear regression, which is most likely the next what we'll be doing next, and as it falls under supervised learning, right? Which talks about labeled data. All right, so you also need some statistics and probability. So you need core statistics like descriptive statistics, talking about mean variance and standard deviation. You need to know about loss functions, that maximum square error or so. Yeah, or is it mean square error? I think it's mean square error. So where you have 1 over n summation. So yi minus yi bar is talks about the deviation, right? Talks about the kind of loss. So when you square it and you take the average of it, that's why it's mean square error. So it's a very good way to measure how well your model is performing. Then there's the idea of cross entropy. You have evaluation. You want to do evaluations of your model, like using ROC curve, AUC, confusion matrix, and all that. You also need some probability, like basics, like conditional probability that an event A happens, given that B had happened in the past. Then you need that. So that idea of conditional probability fits into Bayes' theorem, right? And there's a whole field called Bayesian statistics. So it's based on this idea of conditional probability. And you need to know about distributions. Interestingly, most of these things I've covered them in my probability and statistics playlists, which I'm going to show you very soon on my channel. So distributions, you need to know about normal distribution, Bernoulli distribution. All of these have also been taken care of under, I think, statistics or probability, one of the two. Then you have applications like naive Bayes, uncertainty quantification, and machine learning. Those are the areas where you apply all this probability and distribution stuff. Then calculus is really important here too. The most of the times, many people don't get to see the mathematics, but you need to know that's why you need to get the basics right. You need to get your vectors, matrices, eigenvalues, derivatives, Optimization, yeah, optimization, numerical optimization techniques. And I have all these playlists on my channel. They can serve as a good foundation for you. So you need calculus essentials like derivatives, where you talk about gradients. That's the differentiation of f, right? And then that leads us to optimization. Then you can talk about the idea of gradient descent, which I've also treated under numerical optimization techniques. You need to know about integrals, which when it comes to things, talking about things like expected values, which is the integral of a value multiplied by the probability of that value, summed up. All right. So, and you have application in places like optimizing loss. You want to optimize loss functions, e.g., in back propagation. Then you need linear basic algebra basics like vectors and matrices. You need data as matrices and transformations, e.g., AX equals B, right? So data, the whole idea of coding and all that is based on representing information as matrices, because it's a very efficient way of handling data, right? You have rows and columns. That's the basic thing you even have in spreadsheets. And when it comes to principal component analysis, where you talk about eigenvalues now, so you have this kind of expression, which is something that you do with matrices. Then you have a good application in neural networks where we talk about weights, and you also have it in dimensionality reduction, talking about PCA in that regard. So, talking about supervised and unsupervised learning, right? These are two of the important areas of machine learning, right? So for supervised learning, you have different examples like linear regression, where you have something like y cap equals w transpose x plus b, and then you can minimize the mean square error. That's the idea here. Then you can have logistic regression, where you have a sigmoid function. A sigmoid function is a function that reaches a kind of saturation, and this is good for something like binary classification, right? You have support vector machines which maximize margins. So where you have maximum of 2 over the norm of W subject to yi, blah, blah, all these maths. So we are going to see all of these things step by step as we move on in this playlist. Okay. Then we have decision trees still under linear regression. Here you split via Gini impurity. You have random forest, which is an ensemble via bargain. And then you have example like predicting house prices or spam detection. So we are going to practicalize all these things as we move on. Then unsupervised learning, on the other hand, you have examples of unsupervised learning like clustering. Clustering is like grouping things together, kind of. So where you have to deal with things like k-means, where you want to maximize a kind of an expression like this, right? Then you have PCA, also principal component analysis, where you project data onto eigenvectors of covariance matrix. Examples lie in maybe having customer segmentation. You want to see which customers buy a particular kind of product, or what is the age of customer that prefer this kind of product, right? Then it's also useful for things like image compression. So for evaluation, you need things like silhouette score, explained variance ratio, and all that. That's for supervised learning. Okay. For model evaluation, right, you need metrics like precision. Precision is true positive. Here we talk about things like true positive and false positive. So true positive all over true positive plus false positive gives you precision. How precise is your model, right? Then there's recall, there's AEC. We're going to talk about all of this as we move on. Then there's cross validation, where you talk about k-fold. Here you split data into k sets, right, for cross validation. Then you have tuning. You can have grid search for hyperparameters. So this can help to make your model better. Now you're going to get this better as we get into actual application with Python codes. Okay, so that's what we've had so far. So you want to launch your machine learning journey also by subscribing and joining and exploring with me on my channel. Of course, this is my, if you click this, you get my YouTube channel. So here, it's about math, life's complexity, and timeless wisdom. So basically, I have a lot of videos on mathematics, different aspects of mathematics, data science, scientific computing. I get to talk about scholarships also. Then I talk about AI, right? Most of my shorts are dedicated to talking about artificial intelligence, right? So some of my popular videos are on Okay, the welcome video, of course, we as expected. Then I've talked about simplex method under linear programming. I've talked about stepping stone method also. Then I talked about next scholarship that is almost closing now. The embassy recommendation is almost closing. So that's a brief overview of my channel. Then you can also subscribe. So the least thing you can do is to subscribe. That's totally free. You don't have to pay for that. So you just I think yeah, if you use your own uh, connection, you see how you can subscribe and then hit the notification bell so you can always get alerted each time I release a new video. So you can feel very free to subscribe. Another thing you want to do is you can also you can become a member, right? So you can become a member. Now, with this, now you get beyond being a subscriber, right? You can get special privileges. So for now, there are three levels of access. You can have the EJD bronze access, silver access, or gold access with different levels of perks that you get depending on uh, how far you want some special privileges. Okay. Then you can also explore playlists. You know, from what I've just done so far, you see, you need information, you need some background knowledge on things like starting from the beginning, right? So I began, well, started talking about matrices, and then from there, I talked about basic calculus, which is also useful. Mathematical induction may also be helpful because sometimes you need to do some logical reasoning to get things done. Scientific computing with Python. So this is where you get things like NumPy, basic ideas of Python, data structures, data types, and everything. Set theory also can be helpful. Then you need vectors and matrices. Vectors and matrices often go together. So like that, you need some idea of probabilities, statistics, linear programming. All right. So it is in linear programming, you find things like simplex method. All right. And there's graph theory, game theory, sequences and series, binomial series, Fourier series. Some of these things can be really useful. Generating functions sometimes under statistics. And numerical optimization techniques are also very useful. This is where you find things like different methods like gradient descent that I described over there, Newton's method, conjugate gradient, Neldar's method, genetic algorithm. So all these different methods, you know, so they are also very useful in machine learning, right? So you want to explore the various playlists as you go on this journey. Okay. So you see numerical, there's also numerical analysis which can be really helpful, numerical optimization, and of course, leading shortly up to the idea of data sciences, the data analysis with Python, SQL with Python, they all connect together, lead up to data science with Python that we are now talking about, right? So you want to explore all of that. Then, of course, by the time you get more and more confident, you want to, engage with Kaggle competitions, GitHub machine learning repositories. You want to see what others are doing and then also get to do your own as you build confidence. Okay. So feel free to subscribe. Don't forget, become a member for special privileges if possible. Then explore playlists. So if you need to build up your knowledge on one aspect or the other, you want to do that so because as from next video, I'll begin to talk about supervised learning. I will take all these concepts one after the other and get through them gradually like that. Okay, so if you have not subscribed to the channel, you want to do that right away and hit the notification bell so you don't so you get alerted each time I upload a new video. Then you definitely want to like and share also so that more people can have access to the great content I have going on here. And always feel free to let me know how helpful these videos are for you. Till I come your way again, keep doing data right. Bye.